Example 3, determine the area of the region between y equals sine x and y equals cos x from 0 to pi. So I did my best to draw my graphs here. And so we're looking at from 0, here's 0. So we have this region, and then they intersect to pi. So then we have this middle section right here. Okay, so I have two regions. We have region 1 and region 2. And I'm going to need to know what this intersection point is. Okay, so I have to think, where does sine x equal to cos x? So when you're thinking about this intersection, hopefully you're knowing that that's pi on 4. Okay, where does sine x equal to cos x? Okay, it has to be at pi on 4. Where are they exactly the same on my unit circle? Okay, so they're root 2 on 2, root 2 on 2. That's where they're exactly the same. So that's how I did that question for my intersections, okay? This is all this 30 trig stuff, which is really important that we still remember. Okay, so in region number 1, who is the upper? Okay, in region 1, the upper graph is cos, okay? The upper graph is cos. So I'm going to split these into two again. So we've got region 1, and the upper is cos. Okay, upper is the cos graph, and the lower is the sine graph. So upper minus lower is cos minus sine. That's region 1. And then region 2, the region 2, my upper is my sine. Okay, region 2, upper is sine. Okay, so upper is my sine, lower is my cos graph. So upper minus lower will be sine x minus cos x. Region 1 is going to go from 0 to pi on 4. So when I'm calculating my area, the furthest boundary is pi, right boundary. But I have to do these in two chunks. I have to do my region 1 and my region 2. So region 1 goes from 0 to pi on 4, and that function is cos x minus sine x in terms of x, so dx, plus region 2 goes from pi on 4 to pi of sine x minus cos x in terms of x. All right, now we get to integrate, okay? So just remember that this is region 1, and then this one is region 2. Okay, so let's integrate. So the antiderivative of cos is sine. And the antiderivative of sine is negative cos. So I'm subtracting a negative there. And I'm going to evaluate this one from 0 to pi on 4 and add it to the second region. So the antiderivative of sine is negative cos. Subtract the antiderivative of cos is sine. And this one's evaluated from pi on 4 to pi. Now we're going to substitute in and see how our trig math goes. Okay, so we have that this is equal to sine pi on 4. Okay, so I could make those two negatives here become a positive. Let's do that just to tidy this up. That becomes a positive. All right, down we go again. Okay, so sine pi on 4 plus cos pi on 4. Subtract sine 0 plus cos 0. Remember, that's the angle 0. All of this is region 1 plus region 2 would be negative cos pi minus sine pi, all of that. Subtract negative cos pi on 4, subtract sine pi on 4. Hard to fit it in. Okay, now we have to know what our values are. Okay, so sine pi on 4 is equal to root 2 on 2, plus cos pi on 4 is root 2 on 2. This number, subtract. Sine 0 is 0. Cos 0 is 1. Keep that in brackets because we're going to subtract it in a minute. Plus, now region 2, negative cos pi. So negative 1, because at cos pi it's negative 1, minus 0, because sine pi is 0. That can go in brackets. Subtract. Negative cos pi on 4 is root 2 on 2. Subtract sine pi on 4 is root 2 on 2. And let's tidy this up to find our answer. Okay, so root 2 on 2 plus root 2 on 2 is 2 root 2 on 2. Subtract 1. That's the first one. And then what happens over here? Negative and a negative makes a positive 1. Subtract, what do we have inside here? A negative and a negative. So we have negative and a negative making me a positive. Root 2 on 2 on 2. Okay, so this piece right here is negative root 2 of those on 2. And then I'm going to subtract that, which makes this become a positive. Ooh, there's a lot of negatives happening in this question. Okay, so I could cancel out these 2's. And now I have negative 1 plus 1. Actually, I have root 2, negative 1 plus 1 plus root 2. So the 1's are going to cancel, and I'm left with 2 root 2's. So the answer is 2 root 2 units squared. Don't forget to write units squared. Whew, tricky stuff. Okay, example 4. Find the area between the parabola y squared equals 4x and the line y equals 2x minus 4. And this one is saying, think sideways. Weird, but true. Okay, so this is funky. Y squared equals 4x. If I had y is equal to 1/4 x squared, let's say, I would know that that's a parabola with a vertical stretch of 1/4. Okay, so what happens if I move the 4 to this side and I say x is equal to 1/4 y squared? Okay, that's why it says think sideways, because you could actually think of this as a sideways parabola, and it would have a vertical stretch of 1/4, but opening to the right. Okay, the other way is to say that y squared is equal to 4x. I'm going to isolate my y by taking the square root, but then I'd have to take the plus or minus. And if I take the plus, I get the upper, and if I take the negative, I get the lower. Okay, so we do end up with a sideways parabola. And then we also have the line y equals 2x minus 4. So it's got a y-intercept of negative 4 and a positive slope. So here we go. So we have y squared is equal to 4x as my sideways parabola. I'm just going to erase this piece here. Erase that. Okay, and then I have this slanted line as y is equal to 2x minus 4. Okay, so I've done this as a sideways parabola, and the area between the two is this region right here. And it's a little bit tricky because there's a portion above the x-axis that has both curves involved, and then there's a portion below which is kind of funky because who's upper and who's lower and whatever. So actually, I'm going to actually turn this and look at it sideways. Okay, I'm going to look at it tilted to the 90 degrees. So I'm looking at it from this direction. And then it just becomes one nice region with my upper part being the y equals 2x minus 4. And my lower, if I'm looking from the right, is actually my parabola. Okay? So the other part would be that I need to know what these intersections are. And I'm going to actually work in terms of y in this question because I'm looking at it from a sideways perspective. So I want to know what the y values are instead of the x values. In order to do that, I need them to say x equals. Okay? So the upper one would be x would be equal to subtract your 4, y minus, add your 4, and divide by 2. And then this other one, we would have that x is equal to 1/4 y squared. So when we go to find our intersections in terms of y, I'm saying where does 1/4 y squared equal to y plus 4 on 2? So 1/2 y plus 2. Yes, so hopefully you're okay with that math. And then I can go ahead and solve this. So I have 1/4 y squared minus 1/2 y minus 2 is equal to 0. Multiply everything by 4 because I don't want to work with fractions for factoring. Okay, so then I get y squared minus 2y minus 8 is equal to 0. And that leaves me with the intersections as y minus 4, y plus 2, the factors. So the intersections are happening at -2 and +4 for my y values. Okay, so back here, this is going from -2 to +4. And then my upper minus my lower. Okay, so who's upper? In this case, thinking who's the furthest on the right, when you're looking at it sideways, the upper guy is your line. And that was 2x minus 4, but we want that actually to be in terms of y. So what was that? That was 1/2 y plus 2. And then my lower is my 1/4 y squared. Okay, so upper minus lower is 1/2 y plus 2 subtract 1/4 y squared. And this is what we are going to integrate, but we're going to do it in terms of y. So we have our area of 4 is equal to the integral from -2 to 4 of 1/2 y plus 2 minus 1/4 y squared. And notice here our notation will be dy because we're going to do it in terms of y. Okay, and so this is equal to the antiderivative would be, so we have 1/2 y squared on 2 plus 2y minus 1/4 y cubed on 3. And when we tidy that all up, we're going to integrate this from -2 to 4. We get that we need to go from 1/4 y squared plus 2y minus y cubed on 12. -2 to 4. We plug in our numbers. And I'm getting really close to the video ending. If you don't want to come back and look, this works out to be 9 units squared. Okay, I'll come back and finish this quickly in the next video if I have to. So once you plug in, you've got 1/4 4 squared plus 2 times 4 minus 4 cubed on 12. All of that. Subtract 1/4 -2 squared plus 2 times -2 minus -2 cubed on 12. Okay, so when you do all of that, maybe I do get it finished before the video is over. You get 20 on 3 subtract -7 on 3. Which is 9 units squared. Woohoo, I finished before the video crashed. Yay for me. Okay, There's a u-try. I'll come back in the next video and do the u-try. For those of you who would like to see what this looks like